Hi there. Welcome to session 3 of the webinar series, RFID for Local Government, sponsored by Impinj and Hana Technologies. I'm Martha Mallon, Senior Director of Global Partner Marketing for Impinj. And together with Hana, we have been hosting topics and speakers to help you build your understanding of RFID technology and how it can improve the efficiency of government operations. We're going to start with a quick poll. This is a demographic poll to find out a little bit more about the audience. And if you could take a moment to complete that, we'd really appreciate it. Now, in our first 2 events, we had a lot of questions about what you can label, how you can track and locate and do things of your assets in local government operations. Today's topic is designed to dive deeper on the structure of an RFID tag, how it evolves to tags and labels that you use on your assets to fit the item of the type of thing you want to tag. And then we'll provide some practical steps on how you can get started in tagging. Our featured partner is Repacorp Incorporated, Quality Labels and Packaging. Repacorp has manufacturing located in Ohio, Wisconsin, and Arizona, and is headquartered in Tip City, Ohio. Repacorp's mission statement is to deliver quality label and packaging products and a positive customer experience on every order to keep customers for life. Now, before I introduce the speakers, if you guys could wrap up that poll, we're going to do a second quick poll, and this one is to help the panelists understand more about how your organizations are tracking your assets today. Let us know if you don't track assets in general, or you use an Excel spreadsheet, or you're tracking with other technologies. We will share the results of this poll later in the session. While you're completing that poll, I'd also like to point out 2 features of Zoom events that you should take advantage of today. The first one being your Q&A panel. All audience members are muted, but if you ask any questions of the speakers and the panelists throughout the session, we'll incorporate them into the Q&A and the panel at the end of the session. The second feature is the resources folder. This folder contains helpful RAIN RFID resources from the series sponsors that you can download, so be sure to check it out. There's a couple of links to some interesting blogs as well. So thank you for completing that poll. Let's introduce today's speakers and panelists. Our first speaker will be Scott Worthington from Hana Technologies. And we'll also have Rochelle Heinl from Repacorp. Then at the end of the presentation, we'll have the panel discussion that will also include Paul Brown, Vice President of Sales for Hana Technologies, and Joe Gomillion, Senior Sales Director for Impinj Endpoint ICs. Thank you all for being here today, and I'm handing it over to Scott.
Hello, everyone. Little technical difficulties on the PowerPoint. Just a moment.
And Scott, we need you to turn your camera on too, so we can see you.
So many buttons.
Too many buttons. Sorry about this. My camera is not turning on, and it did a minute ago.
We can see your PowerPoint, so if you want to start
Okay.
sharing. There we go.
Better?
Perfect. Go on. You can go ahead and run your PowerPoint now.
And it's not indexing, unfortunately.
My suggestion is on your PowerPoint screen, just literally put your mouse on the PowerPoint screen and click it, and that should probably move it forward.
How about this?
There you go. Now that was the introduction of all the speakers. Excellent.
All right.
There you go.
Sorry about that, everyone. I'd like to introduce Hana a little bit. So we started in 1978 in Thailand, Bangkok, and we started in electronics in a watch assembly when the LED watches were coming out. In 1992, we entered the RFID market. a lot of hand wound coils and near field applications. In 1999, we started Hana Technologies in Ohio. Hana purchased a startup company that had some technology, and we built the business from there. Around 2004, RFID asset tagging was taking off. We looked at that technology as something that would add to Hana's portfolio, and added bought a piece of equipment and placed it in Ohio for building inlays. And around 2022, we expanded that process into China and installed equipment over there and getting that qualified. And then in 2023, we're now in Solon, Ohio, in this new facility at about 3 times the square footage, and have been building focused on RFID inlays and embedded tags. For new product development, so typically when a customer comes to us, has some type of an application, they will, here's my situation, this is the business market, does it make sense to us to go ahead and pursue this? We will have a stage gate process, so we'll discuss that as a business and go through stage 1, and if we decide that we're going to pursue that, then it goes into stage 2, which is kind of the key of inlay design, right? So I know now what I'm going to put it on. I design a tag for that. I test it. And I validate it as a new product. If everything looks good, it meets all the performance requirements of that industry or that customer, then we would run a pilot. When we run a pilot, we take it's run on production equipment. We would take yield data, performance data, and then do all the testing required to become a product, basically. TNH testing, temperature cycling, bend testing, make sure it performs well and it's reliable. If it passes all those stages, we go to a stage 4, which is a production readiness. It has all the documentations in place, and sales can go certify these things for different, for example, ARC or TIP. They can and get customer approval, and we would release that as a product to the market. So what is a inlay? We typically buy material that has patterned inlays on it. This is in most cases it's aluminum that's been etched off. Comes in a roll format. Up in the upper right corner, there's a roll of antenna. So it comes on about a 50 micron PET substrate that's heat stabilized. So when we apply heat and pressure to put the die on, it can withstand that temperature. We have the conductive patterned antenna. We use an anisotropic adhesive we dispense on there, and then we use an RF silicon die on top of that, and then we use thermal compression bonding to make that connection to the antenna. The next thing is design considerations, right? So for designing an antenna, right? Well, what die do you want to use, right? There's several out there on the market. There's Impinj, NXP, there's some Alien still, a lot of different vendors you could use. What type of standards do you need to meet? ISO, EPC global standards, for example. What frequency band are you targeting? And is it a European band, or is it FCC band in the US? And what kind of memory allocations does that die need to have on it? Some people want a little more memory, a little less memory. They use the different embedded memories that's on the chip for different things. So we look at the die first, because that's the key to the performance. The target application, what's it intended to use on? Is it a retail? Is it automotive, pharmaceutical? What are they going to use this tag on? The form factors are extremely important, right? If I have a larger tag, it's going to have more surface area to collect energy and power up the chip and send that energy back to the reader. If it's smaller, it's harder to do that. So you have to take that into your consideration when you're making the designs. What materials is it going to be placed on, right? So if I place this on a cardboard box, I put it on a uniform label, I put it on a badge. All these things can have a significant impact in the performance, and that's something you need to be careful. You can have one result on one material, and it completely shifts your performance when you put it on another material. So you need to understand that very clearly. Specifications, read, write, performance requirements. What distance is this person needing to read? Are they using handheld readers? Is it going to go through a portal? What type of application that's going to have to meet, and what distances it will have to do in that application. And then what certifications it has to meet. A large one we use is ARC here. ARC is a system that takes all things in consideration for different angles and different materials. And once you get certified, then a customer can just select from that category and use it on those RFID performance is a big key factor. I'm just showing one example, right? So the red line is a previous die. It's Impinj's M8730 die. They've come out with a new die, an Impinj M830 die, which gives you some additional read range performance. This is placed on the same antenna, so I didn't change the antenna design. I just changed the chip only, right? And we got a nice bump in performance. So we can actually now adjust that frequency, tune it for different applications, different materials, and maximize our performance of that application. So once we've done that, we do a product launch. We basically read this tag on the different materials, and we'll show examples of that. We have expected performance on cardboard. It could be a uniform fabric. It could be plastic, glass, metal parts. But this is just an example of something that we produce. So you could at least have an idea on how these things perform. And you can see there's a variation in read range depending on what materials you place it on. Here's a few examples as well of different form factors. We have things like a 2720, which is a small round device that goes on the bottom of plastic bottles, for example. And then if you have sometimes they have to read on a rubber tire, for example, something like an 8040 for an automotive application. We have small thin ones, 9508s, for example, or have a really good read range, great performance over the frequency bands, and good performance on different materials. But it depends on the customer's applications. A lot of times they're driving everything smaller and smaller, because that will drive the cost down of the label and the inlay. So that makes it more challenging to read everything. Now, how is it manufactured? So here's a picture of Hana's facility. We currently have 6 high volume roll-to-roll machines. So basically load the web on one side, it dispenses the epoxy, it does the places the die, thermal compression, bonding, and testing, and sends these rolls. We have about a 3 billion capacity per year currently at Hana. And then after we've manufactured these things into inlays, they need to be converted into labels for different applications, different materials. And we work closely with our converting partners to turn these into inlays into our final products that are used in the industry. And with that, I will pass this on to Rochelle, and that's all I have for today.
Hello, everybody out there. Happy afternoon. I hope you are having a really wonderful day so far.
Rochelle?
Yep.
You need to switch your slides from display settings. We're seeing your notes.
Oh,
So upper left corner where it says display settings, or yeah, switch the, swap presenter view. I think swap presenter view.
Oh.
There we go. That's it. Very good.
okay. Hi, everybody. Nice to see you all. Thanks for attending today. My name is Rochelle, and I work for Repacorp Label Products. Michelle was unable to make it today, so you just get me. Sorry, guys. We are headquartered in Tip City, Ohio. We've been around since 1974. We convert a wide variety of different labels. Often you guys will call them stickers, but we can do printed colors, wide variety of different label materials, tags, adhesives, in asset tagging. A lot of people want to know, can they put a barcode? Can they put a company logo? We have the ability to do all of that within adding the RFID to your product. RFID, for those of you who are a little bit more basic in this industry, RFID stands for Radio Frequency Identification Device. And what it does, it essentially takes the chip and the antenna, it puts it into a label, and then it emits a signal that allows technology to be used for a barcode. So if you look in the bottom right-hand corner, you can see the UPC the original UPC barcode that was used. The positive thing about barcoding is that it gives you a good way to track things. The negative thing about barcoding is that you have to have the line of sight for it. So in order to utilize a barcode, you have to scan the barcode. RFID, on the other hand, is a technology. So you take your wand and you walk into a room and you say, I'm looking for this object, and RFID emits the signal. You have your power source on your hand scanner. The power source is your hand scanner. It looks for this signal in the room, and once it finds it, it helps you identify it. So Repacorp got involved in it because we were involved in helping with the first UPC barcode, and we saw how that technology took place and what it allowed other companies to be able to do. And we thought, heck, RFID is just as good, if not better, in so many areas. We want to be a part of that. Today, RFID technology is like many technologies in that it kind of started off in some areas, libraries, toll cards, subway trains were all good areas. And now things, even like your credit card today, have RFID enabling in them. So for areas of government, there are a lot of different areas. Asset management would be an entirely feasible, quick, and wonderful way that you could get started. If you think about how many cases that you need to find, how many documents that are critical that you need to be able to keep traceability when it's going in a room and out of a room, and people might not be doing that. RFID takes the human error out of it. You can put portals up near the doors, and when somebody walks in and out with a file, it'll track that against their badge if they have a badge, or it'll timestamp it, and you can look back at a video and see who took that file in and out. There are some companies, Parks and Rec, that they want to say, okay, how many trees do I have out there? How many lived through the year? How many didn't live through the year? Our company converts such a wide variety of different materials that we can also do plant hang tags. And while metal and liquid don't play very well with RFID, the metal reflects the frequency, not always allowing the frequency to go back at the reader, so you don't get an accurate read all the time, and the water absorbs the frequency. So those are some areas where you're going to have to get a little creative with the way that you're tagging. You're going to have to talk about synthetic materials instead of paper materials. You might have areas where you're going to be in the cold and your winters are going to get quite chilly. So you're going to have to look at an adhesive that has an all temp situation to it. But a lot of people, visitor management, when people are coming in and out, you want people to be able to tour an area, but you want to know where they're at. You can use RFID. Take into consideration that if you put an RFID tag right on somebody's chest, humans have water in them. So there are different ways that you can track them. You can put foam, you can use, like, a lot of running participants are now using RFID. So there are a lot of areas that you can utilize this technology. And it's challenging sometimes to just say, oh, tell me exactly how I can use RFID, because so much of it is very customizable to you and your environment. You may say, I have these 5 wrenches and I need to either know where they're at all time, or I need to know if it's going to come in and out of a room. Well, you would think those two things are the same, but when you're setting up the software and the technology and labeling it, that might be done in a little bit different approach. It also depends on the budget that you have. If you have a $5,000 budget versus a $50,000 budget, depending on what you're trying to accomplish and the hardware necessary to do so, you might take a little bit different path to accomplish what you need. So I'm trying to give you as much information as I can on a high level, but if you have any specific questions, please feel free to ask them at the end, or I'll give you my contact information. We can help you talk it through after the fact. I know the team from Hana can as well. And I don't know, Martha, do you want to pull up the poll so we can see where some of these fine folk are from? Do we have the polling results? Okay, so looks like 59% of you are local government. We have some state government, academia. Hope you guys can teach me something. Some industry and a few others. So, and it looks like you're all in the United States. So I just got back traveling internationally, and I got to be honest with you, America's a great country. I'm super happy to be back with you all. So when you're looking,
let's bring up that second poll too.
Okay, sounds great.
Coming up here. Here we go.
So it looks like 17% of you are not tracking your assets. And I guess that leads me to the question of, why are you not tracking your assets? Do you not have somebody in the technology space within your team that understands the use of either a barcode or RFID? Are your assets not high value enough to be tracked? And I think when you're looking at RFID and or a barcode, really any tracking for that matter, what's beneficial to you as a department is to say, what in the heck am I missing? Why does this keep walking off? Why are we always rebuying this lawnmower or screwdriver or whatever that piece of equipment is? If you're having that conversation weekly or monthly, then that leads you to the next conversation of a cost analysis. How much of that am I losing? Why am I losing it? How much time does it take if it's lost? And how much time does it take to replace it? So those are the conversations that get the use of RFID going and help you determine there is actually a cost. It might be a soft cost instead of a hard cost, but there's definitely a cost with losing these things. And how do I now deplete some of that cost and keep what I have? Can they see these poll answers, or do I have to tell them?
They could. Nope, you're good.
Okay, sounds good.
Right.
It's exciting to see that some of you are already using automated technology and barcodes. So that's pretty awesome. Congrats to you guys. That's very cool. So when you're talking about RFID and a label, Scott did a great job of showing you what just an RFID tag looks like. So if you look in the middle of the screen, I have a 3-ply image. It has a barcode on top with the RFID antenna in the middle, and then the liner on the bottom. So you're going to see that from my team or somebody that's converting a label. And with RFID, they'll take the inlay that a Hana or one of the other suppliers manufacture, and they'll insert that into a wide variety of materials. Some people want to use direct thermal for quick parking tickets. Some people want to use They want to put it on their vehicles. So they want to use windshield tags, and they want to reverse print it and put a barcode on the front and then be able to scan it and or read it with a reader. So it's just all very, it's all very based on what your needs are and what you're missing and what you're trying to accomplish. But people are doing these things every day in many cities. Bin tracking, a lot of people are doing bin tracking. And for cities with garbage cans, believe it or not, people steal other people's garbage cans. It's the craziest thing. So being able to track that, and they're expensive. So, and being able to track your employee use too. Oh, this employee, we're getting complaints about their route. Well, if you put RFID on those trash cans and you put a scanner on the truck as they go through, you can track to see that they're accomplishing what you need. And you can do that in a couple of different areas. Oh, sorry. So we kind of talked about some of the cost benefits to evaluate an RFID system, but essentially the conversation needs to start with why do I need something? Why do I need to track it? Why do I need to trace it? From that conversation, you often can put together a discussion on how much is this costing us? How much is the item? How many times have we lost it? How many times have we been down without it? And then you can put together a cost associated with that. And then there are a lot of people, one of the biggest things that started when RFID started, and especially from consumers that didn't understand the technology a lot, when there was talk about it going into the grocery store or into Target and Walmart, a lot of consumers thought to themselves, oh my gosh, I don't want to shop there anymore. I'm being tracked. And that's not how RFID works. So the privacy and security aside, people need to understand that in order to know what's encoded onto that chip, you have to have the software that decodes the value on that. So that's something that I think you probably just need to address. And I think that's been over the years a reason why people haven't adopted RFID, because they're just scared of the technology. But it's not like a chip that you get implanted in your skin or anything like that that people can trace. If I go and buy a jug of milk and it has an RFID label on it and I bring it into my home, the person that's scanning sitting out there, they don't know anything other than the fact that I drink milk. So one thing to consider on the label form factor is that the antenna being utilized is going to help determine the distance of read. While most women think bigger is always better, with RFID, longer read distance is not always better. So in some instances, like document storage, for example, if you want to track your document storage, if you use an antenna that has too much power to it, you're going to get cross reads and bounce reads. So if you're stacking 10 file folders on top of each other, you're going to need something that has a little bit more linear output and then you can stack them on top of each other. Again, another customizable thing about RFID, depending on your application, depending on how you're utilizing it, it can give you a lot of great opportunity. But for the label side of things, if you're using an antenna, for example, that's 2x2, then the label is going to have to be a little bit bigger than that antenna size. So the size of area you have to tag is going to be critical to determining which inlay you move forward with. If you say, well, heck, I only have a 2x2 space, I can't use some inlays. And I can say, okay, well, then you're going to get a 5-foot read distance. And if you need a 10-foot read distance, then we need to have that conversation. So there are just a lot of different kind of little technological quirks that go with RFID and the environment, and then what you're trying to accomplish in that environment. Just some specs in general about RFID. You can kind of see up in the right-hand corner what it would look like if you put an inlay on the back of a label. There's still adhesive on it, so you can still stick it to something, but it has the inlay there, encoded, tagged. You can print we print 8 colors, front and or back. We can encode what you need to the data. You can put a barcode. You cannot put a barcode. You can do synthetic materials, paper materials, with adhesive, without adhesive. We can do flag tags that go off of the metal, so we'll help you get a read. And then a couple of slides before this, you saw a vial bottle that had a barbell tag off to the side of it. So that's kind of RFID 101 in a very, very basic nutshell. I really appreciate your time today, and we're looking very forward to hearing the questions that you might have from the small amount of information we were able to provide you. Thank you, everybody.
Great. Rochelle, hang out here. I'm going to ask our panelists to join us. We have a question from our Q&A panel directly to you.
Okay.
Question for Rochelle at Repacorp. Does Repacorp have the capability to do 100% inline testing of RFID labels, especially when those labels need Service Bureau?
Yes, they do. So we have different equipment that allows that will scan the inlay after it's been encoded, and it'll test the accuracy of it. So while we can do 100% verification, I do want the user base to understand that when it ships our place, it's 100% verified inline. We have a lot of companies that do auto application, and so they require that. But RFID it's like a little, piece of glass, basically, that chip. So in transit, if it were to get jostled aggressively, or if you pick up the roll and throw it on the ground when you get it, those chips can crack. So it's also a user requirement to understand when they receive the product that it has to be handled with a little bit more delicacy than a standard roll of labels would be.
Great, great. All right.
And we're doing 100% test at the inlay level as well.
Perfect, perfect. Here's one. We've had a couple of different terms used for the tag chip, die. Can we explain the difference between, what is a die and what's the best way to understand or to look online for the right term? How about you, Joe?
Yeah. Die, integrated circuit, chip. Rochelle used chip many times. They're all basically the same word acronym for the brains, if you will, of the smart RFID tags or inlays that we're manufacturing. So yeah, that's really what Impinj does. So the die is, the brains, the smart part, and also drives performance too from an overall system perspective. So yeah, the die is a critical piece, but it doesn't do anything without all the value add downstream that all of the partners add to the overall system in general.
Great. All right, next question. Do you have an RFID label? This probably goes to you, Rochelle, which withstands the temperature below 20 degrees Celsius, and also the tag which has the very good adhesive to withstand the moisture on the asset?
Yes, so very good question.
Cold temperature, yeah.
Yes, absolutely. That can be done. There's cryogenic adhesives that will accommodate that need. So it'll depend on if you want it encompassed in a tag that, for example, would go into a frozen product, or if it would be labeled. We can do all of those things, but also take into consideration that if a chip, an IC, if that were to freeze, it will lessen the performance while the item is frozen, but then as it dethaws, it will start to read again. So yes, we can do both. You would have to do some more thorough testing though to determine that it's going to read 100% at that temperature. While it's frozen, I should say.
And I'm going to ask a follow-up question, and then others can expand on Rochelle's answer there too, because it's similar. What is the approximate lifespan of an RFID label if it is used outdoors? For example, attached to a highway sign panel and exposed to the elements.
Yes. Yeah, so adhesive has come a long way. When I started in this industry 20 years ago, it was 2 years or less, forget it. The adhesive is gonna break down. That is going to be more of where you have your issue. So if you put RFID into a synthetic weatherproof tag, it could last 20, 30 years, no problem. And then you screw it on, it would be more about the affixing. The RFID tag and the inlay and the antenna the antenna and the chip. Once it's inside of the product, the label, the tag, whatever material you're putting it into, it increases the durability of that product tenfold. So the static no longer is going to affect the chip the way it used to. The weather isn't going to affect the chip the way it used to. It's going to be pretty safe and sound there. And I don't know, other people might want to add to that, but.
Yeah, Martha, I was going to say, we have an RFID tire tag that gets embedded into the sidewall of a tire. Very harsh environment, and we've, I think, now traveled 75 trillion miles without one failure. So
Fantastic. Others, Joe, Scott, how about a little bit more about when you're doing the inlay design and you're working it through your manufacturing capabilities over the last 20 years? How has the technology advanced to make stronger, more durable inlays?
From a durability standpoint, I mean, the adhesives that we use to attach the die to the inlay have changed. The chip manufacturers have changed their layout slightly and done some things to make the chip a little bit more robust. Done some different things in the processing of the wafer manufacturing. And just the processing that we use to the equipment's become more sophisticated, and the process that we use to attach the die has become more sophisticated as well.
yeah,
Great.
I would say manufacturing yields have gone from probably 60% up to 99.8%. So come a long way and since we started in this business.
Awesome.
You
And Joe,
stole
the
my,
chip
you stole
vendor,
my thunder, Paul. That was
Yeah, sorry.
that was a good one. I wanted to talk about that transition over the last, 20 plus years, like Rochelle's
Yep.
talking about, the durability overall. I remember when a little bit of static created just huge amounts of problems. If you remember, through the converting process, not anymore. Like the technologies built into just the chip itself to counteract that have
Yep.
come a tremendous long ways. And the durability, quality, robustness, absolutely has been massively improved throughout the years.
fantastic. So now now there's a question here about data. So can RFID be combined with the data that from the unit that it's reading, like a meter, like a utility meter, so meter reading? So who'd like to answer that one?
I could jump in. I would say yes. There's absolutely no reason why you can't take information from the unit itself and then transition that to the RFID tag. It might have to be done through software. You'll be able to keep a running track history on that particular item and then the data that you're trying to store on there. So maybe it's something stored in the cloud. But yeah, there's no reason why you can't create that with the right kind of solution or system where you can make those kind of connections real time.
Yeah, I'm going to piggyback on exactly what Joe said. I couldn't agree more. So I think, so with RFID, there's passive and there is active. Whenever you're using RFID technology, you have to have a battery source to utilize the product. So what we're primarily talking about today is just kind of a passive technology. So you have these inlays, these antennas that you've seen. They're encoded with, let's say, 1, 2, 3, 4, 5. And what makes RFID so unique versus a barcode is that a barcode says, okay, I have these 2 Campbell's soup cans. Both of them are item 1, 2, 3, 4, 5. But with RFID, it says, this is can 1, 2, 3, 4, 5A, and this is can 1, 2, 3, 4, 5B. With the same UPC number, basically. It's called an EPC code that's encoded to the chip. So you get this information and it's encoded to the chip and it stays on there and it's static. It can be locked, it can be protected so that other people can't write over it. But the only person that knows what it means is the person that has that encoder that's saying, okay, now what data did you put in there? Let me read what it was in there. So I think one of the misnomers about RFID is that it does something. It only does something if the software around it tells it to do something. So you could easily put software on there that says ping this every whatever time and let us know that it's still there or whatever the information you're looking for at that time. Or you could use an active RFID that would then interpret the information because it has that power source on it. So again, back to the kind of customizable environment that you're looking for, there's such a vast amount of use, and to this guy's point that they've already said, the durability of it, the sensitivity of the chip, the amount of data that you can now encode to a chip. When we started, you used to be able to put like 10 binary digits on the chip. Now you can put, like, 24 binary digits on a small chip, and on a big chip you can put a shit ton more. So it's just depends on what your environment needs, what you're going to do with the data. There are a ton of options out there.
Yeah, re-encoding too, Rochelle. You can encode and then go back when you do your next round of maintenance. You can do a re-encode with new data if you've got the right chip with the right amount of information there. So it's just expanding on what Rochelle's saying. Just so many more applications that you can use with the same software, same reader, same chip, as you try to take advantage of it.
Fire extinguishers. If you want to confirm when the last time it was serviced, you could re-encode it with the date of your last service, kind of thing. Yeah.
Yeah, on the tire tag, we track the retreads of the tire same way.
Over and over. That's right.
Yep.
Now here's a similar question. But it's kind of expands on what you guys have been talking about. That with the information encoded on the chip, can the data be protected or encrypted so other readers can't read it?
Yeah.
I'll jump in on that one. Absolutely. Yeah. You definitely can encode it and lock that. You can permalock it so that it's unchangeable, if you will, without destroying the die. And then we have a feature called protected mode, where you can actually encode data in it and then assign a pin to the chip, if you will. Basically, the tagger inlay becomes invisible when you're trying to read other tags in the environment. And you have to present the right pin with that feature and able to turn the inlay or tag back on so that you can see the data that it has to present to the reader. So there's, again, just different features built into the IC and the different capabilities that it has, and how you want to allow the data to be shared or not shared, or protected permanently or not. So you have a lot of different possibilities there.
Fantastic. So there's one final question that's in the Q&A panel. So I invite anybody who still has some lingering questions to quickly add them before we wrap up. This one is a little bit specific to Repacorp 2. That goes back to the cold question. The person says, how can I contact Repacorp for the customized label switch for a temperature-based tag? So Rochelle, help people understand how they can reach out to you.
Let me put my presentation back up here really quick.
Last slide. And of course, we'll pass on some information for the folks that asked the questions.
Sorry, you have all my notes. I didn't put you guys back out yet.
Very last one there.
Scan down, click down.
There you go.
There we go. So if you, well, what in the heck just happened? Can you guys see it?
No.
No.
Booger pants, me neither. Hold on a second. Let me just put it back up this way.
I was gonna say we could type it in the chat box too.
Yeah. Can you see it there?
Nope. Share. You need to share.
Well, everything's available in the resources too, right, Martha?
The general
the company general information.
General information, but I think I saw that there was a info at, there you go, info@repacorp.com and an 800 number.
Yep.
Also, as a reminder to everybody, this session is being recorded and will be available as an on-demand video afterwards, so you'll be able to see the video of it.
Yep.
Excellent. So that was our final question. I don't see any more coming through the panel. So as your moderator, I want to thank all the panelists and the presenters for your time today, and thank everyone who was able to join us. As Anne from Connect Me mentioned, the recording will be available on the website where you registered. And don't forget to check the resources that are in your resource folder for some really interesting information on the basics that reinforce the things that were presented today. I also want to do a little PR for our next session that will be on September 5th. You'll learn more about advanced RFID applications and the future trends in the technology of the applications of RAIN RFID. Our featured speaker will be Eileen Ryan, president of the CEO of the RAIN Alliance. If you've not heard about the RAIN Alliance, it's a consortium of companies formed about 10 years ago with the aim to advance passive UHF RFID technology through standards, education, and collaboration. Very much like the partners that you see on the screen here, different companies collaborating to make sure that you get what you need. So they also have a mission to drive awareness and foster adoption of the technology. And its vision is for everything in the world to be RAIN enabled, improving people's lives and creating sustainable future for our planet. So Eileen promised to give us lots of examples in the government space and of all the things that is possible today and in the future with RAIN RFID. So join us on September 5th. And again, thank you all for joining us.